left child, and right will point to the right child. Now, if let's develop this, and we can implement it using either using a pointer or using using array. So how to first we will declare the simpler method, which is first comes to mind, that how to construct a binary search tree. So in a tree, every node we are considering it as a structure, and each will have three cells. One field will point to the left child, and in the middle field will contain the data for that particular node, and the last cells will point to the right child. Now, how to point to left and right child? We can use a pointer, but that will be discussed or explained later. Instead of that, I'm now discussing that how to implement it using arrays. So, as I have discussed that every node is a type structure. So, to implement the binary search tree, sorting using binary search tree, we will first create the binary search tree where every node in that tree will be a structure. Why it is structure? Because it will have three members. One is pointing to the left children, and one member is pointing to the right children, and the middle another member will point to the current value or data that is stored into that particular node. So in binary search tree, why we need three different styles in a particular schema in every node structure. That is because if we want to get to the parent and child relationship, then obviously alongside the value of a particular node, there will be another point or another variable which will point to your left child of that particular node, and another field will be there which will point to the right child for that particular node. So, and it is a tree for parent-child relationship should be maintained there. So, to maintain the relationship, who is the child of which parent, or so to maintain that, there is a need of defining a structure for every node of that binary search tree. Then what I will do first I will, what is our motive? Our motive is to do the sorting using binary search tree. As suppose I have a number of elements have been given, and it is stored into an array. So suppose there are 10 number of elements given to you, which you have stored into some array. Now we want the element to be sorted in ascending or descending order. So for that, we are using a structure which is binary search tree. And here, every node in that binary search tree will be a structure which will have three values: left, child, and data. Data will contain the value for that current node. Left and right child will point, or left and right will point to the left children and the right child respectively of that particular node. So here we will, as the array is already given to you, which is of size 10 elements, so we will sort these 10 numbers. So for that we will create an array of structures, and also its size will be the same. That means what is the array that is given to you that you have to do sorting? The same size will be here for the array which is array of structure, and which is giving information about each particular node, and the element of that array is giving you information about the node for every node of that binary search tree. Now we will discuss. Now it is very clear how to create a structure for each particular node. Suppose, so we'll declare a structure Then the zeroth, suppose array has been given to us, so zeroth element is placed at the root node. Then it will considering the next element of the array one by one, and once element is taken from that original array, then that value is compared with the current binary search tree, that is root node. If that value is less than the root node, and if that root node has no other left children, so that new node will be inserted as a left child. On the contrary to that, if the element which is greater or equals than root node and the root node has no children till then it will be new node. That new the next array element will be inserted as a right element of that root node. Now we have constructed a tree where there is a root node where there is one left child and there is one right child. Now that is a binary search tree because left child is inserted if its value is less than root, and right child is inserted and that array element is inserted as a right child if it has greater or equal than the value of the root node. Next, we will consider the next array element by its next we will consider it accessed by its next index value. Now, again, this new nodes, this new element, first it will be compared with the right element, root node. If it is less than the root node, then it will check that whether there is any left child at all. If that there is, in this case, we have already inserted a left child. So now it will consider the left child and compare this new element to this left child or to this left child. If it is less than its left child, then this new node will be inserted as into the next level at the next left child of that particular node. And if it is value is greater than the left child of the root node, then it will be inserted as a right child of that node, which is the node which is a left child of the root node. So so in this tree, the continue we will be creating on binary search tree. When all the binary search tree has been constructed, then we will do a traversing we are accessing each node of the binary search tree. As the properties of that binary search tree is like that, if left